Hello guys, welcome back to my YouTube channel. I am Varsha. My USN is 1V23CD062. I am in second semester. The subject is POP, C programming. Introduction to data types and sizes in C programming. Data types in C are used to define the type of data a variable can hold. Different data types have a different sizes and storage requirements. Understanding data types is essential for the efficient memory usage and program execution. Integer data types. Integer data types in C are used to store whole numbers. Commonly used integer data types include int, short, long, and char. The size of integer data types may vary depending on the compiler and system architecture. Floating point and data types. Floating point data types in C are used to store real numbers with decimal points. Commonly used floating point data types include float, double, and long double. Floating point data types have higher precision but may consume more memory compared to integers. Character data type. The char data type in C used to store the single characters like letters, digits, and special symbols. Char data type is typically represented using ASCII or Unicode encoding. Char data type has the size of 1 byte in C. Void data type. The void data type in C is used to indicate that function does not return any value. Void pointers can point to object of any data type. Void data type is commonly used in function declarations. Size of operator. The size of operator in C is used to determine the size data type of the variable. The size of operator returns the size of the operand in bytes. It is important to consider the size of data types for efficient memory allocation. Size of integer data types. The size of int data type is typically 4 bytes on the most modern systems. The size of short int is usually 2 bytes. The size of long int can vary but is often 4 or 8 bytes. Size of floating point data types. Size of float data types is typically 4 bytes. The size of double data type is usually 8 bytes. The size of long double data type can vary. The buttons often 8 or 16 bytes. Size of character data type. The size of char data type in 1 byte. The size of signed char and unsigned char is also 1 byte. Character data types are used to store individual characters in C. Other data types. Other data types in C include enum, struct, and union. Enum is used to define the set of named integer constants. The struct is used to define the collection of variables under one name. Data type modifiers. Data type modifiers like signed, unsigned, short, and long can be used to modify the basic data types. Signed and unsigned are used with the integer data types to specify the signed or unsigned integers. Short and long are used with the integer data types to specify the range of values they can hold. Limits of data types. Data types in C have specific limits on the range of values they can represent. The limits of data types can be found in the limits.h header file. It is important to be aware of these limits to avoid overflow or under overflow errors. Type conversion. Type conversion in C is the process of the converting one data type to another. Implicit type of conversion occurs automatically by the compiler. Explicit type conversion can be done using the typecasting operators. Typecasting. Typecasting is the process of converting the variable from the one data type to another. Typecasting can be done using casting operators like in, float, etc. Care should be taken when performing typecasting to avoiding data loss or unexpected results. Data type compactability. Data type compactability refers to the ability to assign one data type to another without loss of data. C provides rules for the implicit type conversion to ensure the data type compactability. It is important to understand data type compatibility for the correct program behavior. Enumerated data types. Enumerated data types in C are used to define user-defined data types with the set of named constants. Enumerated data types provide a way to create symbolic names for integers. Enumerated data types are useful for the improving code readability and maintainability. Data type compatibility. Data type compatibility refers to the ability to assign the data type another without loss of data. C provides the rules for the implicit type conversion to ensure the data type compatibility. It is important to understand data type compatibility for the correct program behavior. Bit fields. Bit fields in C are used to specify the number of bits to be used for the particular variables within a struct. Bit fields allow for the efficient use of memory by packing multiple variables within a single byte. Bit fields are useful for optimizing memory usage in embedded systems. Data type alignment. Data type alignment in C refers to the memory alignment requirements of different data types. Data type alignment ensures the variable are stored at memory addresses that are multiples of their size. Improper data type alignment can lead to performance issues and memory access violations. NDNS. It refers to the byte order in which multi-byte data types are stored in memory. Big Endian systems store the most significant byte first, while Little Endian systems store the least significant byte first. Understanding the Endians is important when with binary data networking protocols. Conclusion. Data types and sizes in C programming are the essential for the defining the type of the data variables can hold. Understanding the data types helps in the efficient memory usage and program execution. Mastery of the data type sizes is crucial for writing the robust and reliable C programmings. Thank you for watching the video.